Okay, so now we're gonna go through the next chapter on chemical formulas and equation. So basics, in terms of basics, right? Chemical formulas is actually one of the more important ones because it is throughout the whole chemistry in terms of the foundation and stuff. So let's go through how to go about getting the formulas, and subsequently with the formulas we will look at how to go about doing the equations. Okay, so let's start. Okay, so let's skip this. Let's just go straight into this. So in general, chemical formula is like a recipe. Okay, it's like a recipe that shows the ratio of elements, okay, when they are combined in one unit of a substance. So typically what you'll have is, the first thing, you have the chemical symbol, and then next you're going to have the subscript that indicates the number of atoms of each element present. So if we look at this, there are actually two. For carbon dioxide over here, you got one carbon, you got two elements, carbon and oxygen here. This 2 tells you that there's actually 2 oxygen. Okay, so it's made out of 1 carbon and 2 oxygen. Whereas for this one over here, okay, for water, there's 2 elements, hydrogen and oxygen. This 2 belongs to hydrogen. So we know that for 1 molecule of water, it contains 2 hydrogen and 1 oxygen. So that's the basics of reading your chemical formulas, which most of you should be quite okay. Now, how to go about, so this is about reading chemical formulas. Now, how to decipher or how to decide what's a chemical formula. Okay, now, so let's start. We're going to look at, first thing, the chemical formulas. Okay, formulae. First thing we're going to look at is in terms of elements. Okay, for elements, what are their formulas? After that, we're going to look at compounds, what their formulas are. Okay, so we're going to go from elements to compounds. So first thing we're going to look at is the first one, chemical formulas of elements. Okay, so elements can exist as monatomic, diatomic, or polyatomic. So monatomic means 1 atom. Diatomic means 2 atoms to form the molecule. Polyatomic means 3 or more. Okay, 3 or more atoms to form the molecule. So monatomic elements, let's start with them first. So single atom elements. So typically they exist as uncombined atoms. And where can you find them? All your elements in group 18 exist as monatomic elements. So neon, argon, before that will be helium, so on and so forth. Okay, so this one is your monatomic element. Typically they are group 18. They are also known as your noble gases. Okay, all your group 18 noble gases exist as monatomic elements. Okay, next, diatomic molecules. So these are the elements, okay, which are diatomic. Now, so which elements are diatomic molecules? For those of you from my class, you'll realize that I mentioned to you this thing called H7 before. What exactly is H7? H represent hydrogen. Okay, let me remove this over here. H represents hydrogen. 7 represents this element. So what is this 7? So starting from element number 7, which in this case here will be nitrogen. Okay, you go until to group 17. So nitrogen, oxygen, fluorine. So fluorine belongs to group 17. So hydrogen is diatomic, followed by hydrogen, nitrogen, oxygen, fluorine, and the rest of those elements in group 17. So fluorine, chlorine, bromine, iodine, astatine. So all of these, when they are in their element, okay, they will exist as diatomic molecules. So you can see here, all of them, H, okay, and then nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Okay, so these are your they exist as diatomic molecules. Okay, these elements exist as diatomic molecules. Now, how about polyatomic molecules? Okay, which elements actually exist as polyatomic molecules? So there are these 3 classic ones: sulfur, typically S8, phosphorus, P4. Let me erase this. Okay, P4. Okay, let me show you can see your P4. And last one is ozone, which is O3. So usually oxygen, you just take it as O2, unless the question mentioned that, okay, oxygen exists as ozone. When they mention ozone, then you write O3. Otherwise, typically when they just say oxygen, you are referring to oxygen in the diatomic molecule form, which is O2. Okay, so these are the chemical formula for elements, either monatomic, diatomic, which is the H7, or polyatomic. Generally you have these three. Now how about compounds? Okay, so now we're going to go into chemical formula of compounds. So how do you know what's the formula of the compounds, right? Do take note, compounds have fixed formula. You learn this in element compound mixture. Okay, they are combined in a fixed ratio. So some of them that you need to look at, that's quite common, is ammonia, NH3. This one you need to memorize. Another one that you most probably memorize is methane, as of now, which is CH4. Okay, these are the two chemical formula of compounds that you should remember, okay, because these are, the name doesn't tell you the chemical formulas, whereas the rest of this, okay, actually from the name you can sort of get it lah. Okay, now, so question is, okay, if I don't want to memorize, is there a way to remember, to think of how to go about getting the chemical formulas? Okay, so actually we can, but before we go into that, let us look at some of these interesting chemical formulas first. Okay, so what exactly does, sometimes you see chemical formulas with these brackets over here. Okay, with these brackets over here. So what exactly does this bracket means? So this is like your mathematics, where if there's a 2 outside the bracket, it means that the whole everything inside the bracket is actually multiplied by 2. So in this case here, if I got calcium nitrate, then the formula is Ca, open bracket, NO3, close bracket, 2. This means that there's 1 calcium, there's 2 nitrogen, and there's 6 oxygen. Okay, because these 2 will be multiplied in 2. Okay, the formula here. So recognizing this is important. Okay, in general, why they put a 2 with the NO3? Because NO3 exists as what we call a polyatomic ion. Okay, so when I say nitrate is a polyatomic ion, it is definitely NO3 minus. Okay, definitely NO3 minus. And in this case here, 1 calcium will bond with 2 nitrates. So I know that it will be a calcium 2 plus that requires 2 nitrates to bond with it. Okay, that's why it's a CaNO3 bracket 2. So that's trying to get you to understand why is there that subscript 2 outside the NO3 2, instead of saying, oh, why not just put like that? Why not put like that? Okay, you won't put like this because you won't know exactly what is this N2O6. But by having the 2 outside the bracket, you know that it is 1 calcium with 2 nitrates. Okay? Now, you can go and read this, okay, to just get a sense of how our chemical formulas have evolved along the way. Okay, so now we are using the modern system. The Hill system is the old system. Okay, so can go and read this. This is just extra reading, huh? Okay, next one. So how can we construct chemical formulas? Okay, so we're gonna look at how we can construct the chemical formulas. Okay, so ignore this. Okay, I want to focus on the term valency, because to construct chemical formulas, actually valency plays a very big part. So the valency of an element, okay, is referring to the number of electrons that must be lost, gained, or shared in order for the element to obtain a noble gas electronic configuration. So this one here, okay, we know how to go about doing it, because from a periodic table, group 1 valency is 1, group 2 valency is 2, group 13 valency is 3, group 14 valency is 4, group 15 the valency is 3, group 16 the valency is 2, group 17 the valency is 1, group 18 the valency is 0. So for elements, the valency is actually from the periodic table, knowing which group they are, the 1, 2, 3, 4, 3, 2, 1, 0, tells you the number of electrons it requires. Okay, tells you the valency. So this is the valency. Now, how about ions? What's the valency for ions? So they mentioned that the valency of ions is actually the charge without the sign. Okay, without the sign. So if I got Fe2 plus, the valency of Fe2 plus is 2. How about NO3 minus? The valency of this guy is 1. Okay? So next one, maybe you can try one more. So PO4 3 minus. Okay, PO4 3 minus. The valency of PO4 3 minus is actually 3. So you can see here it follows the charge. Okay, this one minus will be 1 minus. That's why it's 1. Okay. Now knowing the valency is key. It is important. So mentioned here, valency follow the group number. Then for transition metals, typically in the ions, right? So if I say iron 3, the valence, then you know it's Fe3 plus, right? That's why the valency of the ion is 3. So typically you'll follow, the valency is actually follow the Roman numerals of the transition metals. Okay, so it's possible to have Ti 4 plus. This is one of the weird cases, but yes, you can have a 4 plus ion. Now, next one. Zinc, Zn2 plus, so this one please remember. Silver, Ag plus, this one please remember, because this one here you can't determine using the Roman numeral, so cannot be, need to memorize. Okay, so let me put a star here. Need to memorize. Why? Okay, because two things. No group number. Second thing, also no Roman numeral like transition metals. Okay, so all this valency need to remember as well. So this forms the baseline of your formation of your chemical formula. Okay, for your general elements and stuff. The last one is your polyatomic ions. Polyatomic ions. So these are the few that you need to remember. Ammonium. Take note, this ammonium, different from ammonia. So ammonium, NiUm, is NH4 plus. The one that we saw on top was ammonia. Nia, this is NH3. So be familiar, this is ammonium ion. This is ammonia gas. So it is different. Okay, be familiar with the difference in ammonium and ammonia. More practice will help. Next few to remember: hydroxide, nitrate, sulfate, carbonate, phosphate. What are their formulas and what are their valency? So you realize for all their valency, it follows the charge. Okay, it follows the charge without the positive or negative sign. Same for ammonium. Okay, plus means 1 plus. That's why it's also valency 1. Okay, now once you're done with valency, then yes, we can finally go into deducing chemical formulas. We are just going to use this cross multiply method. Okay, so the crossing method is very, very simple. In this method, you just cross multiply the valence or valency of the chemical species. Okay, so let's look at this table here. So first thing, for example, I want to find carbon dioxide. So if I just ignore the di, okay, carbon dioxide, you just ignore the carbon dioxide, just know that it's carbon and oxygen. Then what's the valency of carbon? It will be 4. What's the valency of oxygen? It will be 2. Okay, all you do is just cross over to the bottom right corner of each element. So you cross the valency of carbon, cross over to the bottom right of oxygen over here. The valency of oxygen, cross over to the bottom right of the carbon over here. So once you cross, it will be C2O4. Okay, once you have reached this stage here, always final step is to simplify. Okay, simplify. So once you simplify, 2 is to 4, ratio will be 1 is to 2. So it will become CO2. So typically we won't write the 1 over there lah. That's why we got CO2. Okay, we won't write C1O2, we'll just write CO2. So that's one of them. Then let's look at another example over here. Na plus PO4 3 minus. Okay, this in chemical formulas, knowing how to do is key. That's why we're going through more examples. So another example here. Maybe instead of Na plus and PO4 3 minus, maybe let's try Fe. Okay, let's try iron 2 phosphate. Okay, so iron 2 I know is Fe 2 plus. Valency is 2. Phosphate is PO4 3 minus. The valency is 3. Okay, so what I'm going to do, I'm going to take this to cross over to this side. Take this to cross over to this side. So think of it as Fe2 plus is one cluster like that. PO4 3 minus one cluster like that. So you're crossing it to the bottom right hand corner of the cluster. So once you are forming into chemical formula, all your charges will disappear. So you're going to get Fe3. And because PO4 is a polyatomic ion, you need to bracket PO4 2. As long as a polyatomic ion, you need to include the bracket over here. Okay? So the formula for iron 2 phosphate will be Fe3 PO4 bracket 2. Now what if maybe it is let's try another one. What if it is copper 2 sulfate? So I'm gonna have Cu2 plus because copper 2. Sulfate is SO4 2 minus. How do you know all this? So copper 2 you need to know because of the 2 over here, you know that it's a 2 plus. Sulfate, you need to memorize the ion is SO4 2 minus. So valency of copper 2 will be 2. Valency of sulfate will be 2. So remember, this whole thing is 1. This whole thing is 1. Take this crossover to bottom right. Take this crossover to bottom right. So what you're going to get is Cu2 open bracket, because SO4 2 minus is a cluster, right? So SO4 is a sulfate polyatomic ion. You put 2 at the bottom here. Now you see the ratio here, 2 is to 2, right? So I can simplify it down. So it becomes Cu, because no 1, open bracket, SO4, close bracket. Now if there's no number outside here, no number, it's a 1 there, you can actually remove the bracket. What you're going to get is Cu SO4. So this is the final formula. Okay, so this is how you go about doing the chemical formulas. Be very familiar with the valency, be very familiar with the cross method. Okay, now next, what if I want to deduce the charges on the ions from the chemical formula? Is it able to do so? Actually, answer is can lah. Okay, so for example, I got this thing over here. They ask you to deduce the charge of Al. Okay, they ask you to deduce the charge of Al. Now in general, actually I think this question also a bit lame lah. Okay, because based on the periodic table, you know Al is in group 13. So if it's in group 13, you know that Al will actually form Al3 plus lah. Okay, that's why I think this question is a bit lame. But what if I change? Sometimes I give you this question. I can say K X bracket SO4 2 minus. Sorry, not SO4 2 minus. My bad. Okay. KX SO4 2. Then I ask you. I tell you X is a cation. Find for me the charge. What is the charge of the cation over here? So I know K is a plus 1 because it's group 1. I know that X is a question mark. SO4 I know is a 2 minus. Now because this is an ionic compound, because I got cation and ion, I know the overall charge is 0, right? All the charges, when they add up, it must give me 0. So I got 1K, I got 1X, I got 2SO4, 2 minus. So I know that 1 times plus 1 plus whatever charge of X is, but 1 of X, plus 2 times of minus 2, it must give me the overall charge. Can you see the top corner here? The overall charge is 0, right? Sorry, the overall charge is 0, right? So it equals 0. So if I look at this, I just do my math. So 1 plus x minus 4 equals to 0. X equals to plus 3. Okay, so this is how you go about deducing the charge of the ion. Now I can do another one as well. Let's try another example. What if I give you Y bracket NO3 2? So how do I know the charge of Y? So I tell you this ionic compound. I ask you to find the charge of Y. So how to find the charge of Y? Very simple. You know the overall charge is 0. Okay, it's 0. Overall charge is 0, right? So I know 1Y, the charge of Y, plus NO3 is actually NO3 minus. So I got 2 of this guy here, 2 of them. So 1Y plus 2 times minus 1 must give me the overall charge of 0. So the positive charge plus the negative charge overall must give me the 0, because the chemical formula, the top corner is 0, right? So I know that Y plus minus 2 equals to 0. Y must equals to plus 2. So I know the charge of my Y will be 2 plus. Okay? So I know that Y would actually be Y2 plus. Okay, this is the charge of Y. So you can see how to get chemical formulas, and also from chemical formulas you can deduce the charge of the ions as well. Okay? Now, once we know chemical formulas, we can now go on to look at chemical equations. I think chemical equations balancing is not too much of an issue. Okay? So I just want to say, in terms of reactions, we will normally represent them by, if you really think in terms of step, when we look at reaction, we can represent them in terms of word equation. From the word equation, we can put them into chemical equation. And to get from word to chemical equation, what you need is, the first thing you need is chemical formulas. Okay? Now, this is without state symbol, with SS without state symbol. Now, if I want to do ionic equation, which then later we'll cover, okay, ionic equation, to get to there, you will need one, state symbol. Second thing, you need to cancel spectator ion. Okay, we are gonna look at all these steps. Okay, we're gonna look at all these steps as well for the next part. So we are done with chemical formulas. Now let's look at chemical equations, how to go about doing them. So first thing, equations wise, always take note, this arrow is to tell you the process, right? Okay, anything on the left hand side of the arrow are reactants, anything on the right hand side of the arrow are products. Okay, so in all your reactions you can always have reactants and products. Left hand side is reactants, right hand side is products. Okay, now how to go about getting from word equation to chemical equation? So typically, let's say for example, okay, how do I get this? So look at this chemical reaction here. What you're gonna have is, for example, in my initial word equation, where they tell you sodium react with chlorine to form sodium chloride. Okay, to form sodium chloride. Then they tell you, okay, from this, give me the chemical equation. So they ask you write the chemical equation. What's the chemical equation? So now look at this. Sodium react with chlorine. So I know this guy here is a reactant. Chlorine is also a reactant. Form sodium chloride, this guy here is the product. So I know in my equation, I'm going to have sodium. Sodium is a metal, so I know it's solid. Chlorine. Okay, chlorine is, I know it's a gas, because usually we know chlorine is a gas. Then the last one, sodium chloride, is our usual salt. So salt itself is sodium chloride. Sodium chloride itself, your table salt, exists as a solid. So sodium plus chlorine give me sodium chloride. So the next step is to get from here to the chemical equation. So I want chemical equation, so I need chemical formula. So sodium, I know in the periodic table is Na. So it's an element, right? Okay. So sodium itself is Na, solid. Chlorine is an element. Okay, chlorine is an element. It is one of H7, so it's Cl2 gas. Sodium chloride, so I know it's Na and then Cl. What's the chemical formula? First thing, you need to know what's their valency. So sodium is in group 1, chlorine is in group 17, so valency will be 1, 1. You do your crossover, you know that formula for sodium chloride is actually NaCl. So I got NaCl solid. Once you get the chemical formula, the next step actually you need to balance. Then you can get your balanced chemical equation. So how to balance it? So I know that, okay, you must compare the left and the right hand side. So my left hand side, you realize I got 1 sodium, 2 chlorine. Right hand side, I got 1 sodium, 1 chlorine. Okay, so let's balance them. So how I will normally do is, I will do the very long way just to show everybody. So sodium, I'll just put Na because there's 1 sodium. For the chlorine column, I'll put chlorine, chlorine. Okay. Down here I got 1 sodium. Sorry, I shouldn't put that. Put a new row. So this one is the sodium row. Chlorine here, I got 2 chlorine. Down here I got 1 sodium, 1 chlorine. Okay. So if I look at sodium, actually balanced because the left and the right hand side got 1 sodium each. But for chlorine, left hand side reactant, I got 2 chlorine. Right hand side I only got 1 chlorine. So what I need to do is to put a big 2 in front of the sodium chloride. So whenever you balance, you're balancing that particular substance, the particular product or the particular reactant. So you can't just put 2 at the chlorine. Actually when you put 2, it will 2 times the sodium, it will 2 times the chlorine. So I know when I do this, now my chlorine is balanced, but now I got 2 sodium on the right hand side. Left hand side I only got 1 sodium. So what I need to do next is to just put a 2 in front of the sodium. So I have 2 Na. Over here, there's balance. So this is now my balanced chemical equation. Okay, so state symbols wise, for those of you still not very familiar, actually you got 4 main states: solid, liquid, gas, and aqueous. Aqueous means that the substance is dissolved in water. So typically when you put aqueous, dissolved in water. When you put aqueous, you are actually looking at it in a solution form. So whenever you see a solution, means it's dissolved in water, you will put the aqueous state. Okay, so an example, so when you look at dilute hydrochloric acid, the word dilute means that it's a solution. Sodium hydroxide solution, so we know that both of them are in the aqueous state. Okay, so you can see here HCl aqueous, NaOH aqueous. Then you actually form your sodium chloride dissolved in water, so salt water plus water. Now water, usually you'll put H2O liquid. So water itself, you don't dissolve water in water, right? So you'll never say water is in aqueous state. Water usually is always in the liquid state. Okay, so what I did at the top here is not just chemical equation, I also look at balancing. So this is another, so they've now moved on to balancing equation, which I've done at the top. We can just recap using here. So this is a reaction between hydrogen and oxygen. So hydrogen is a H7, so I know it's H2. Oxygen is H7 as well, one of the elements is H7, so it's O2 as well, so all diatomic. So that's why I got my chemical equation H2O2. What will it form when they react? They will form water. So based on this, you realize, okay, after I got my chemical equation that's not balanced, I'll need to balance it now. So to balance it, what I did previously and what they're doing now is the same. So left hand side, how many hydrogens? How many oxygen? Right hand side, how many hydrogen? How many oxygen? So by doing this, they realize, oh no, I got not enough oxygen. So what I need to do is, I need to put a big 2 in front of the water, right? But by doing this, now there's 4 hydrogen, 2 oxygen. So oxygen is balanced, but hydrogen is not balanced now, right? So I need to put another big 2 in front of the hydrogen. And because it's H2, so it's 2 times of H2, so I got 4 hydrogen. And when I do this, I realize, okay, now the hydrogen is balanced, now the oxygen is balanced. So this is my balanced chemical equation. So this is my balanced chemical equation. One thing to note is that if the question never asks you to write the state symbol, just don't write lah. But if they ask you to write, then of course you need to know lah. In this case here, for this particular reaction, hydrogen is gas, oxygen is gas, water will be existing in liquid. Okay? So if I look at a balanced chemical equation, you can see here at the final state, final part, right, at step 4 at the very end, they will write the state symbols in. So you do your chemical equation, balance it, then after that you go and write down your state symbol. So follow this step 1, 2, 3 and then 4. You won't go wrong lah. Most people die in chemical formulas because chemical equation because their chemical formulas are not strong. Okay, balancing normally not too much of an issue. It's always the chemical formulas. They write the chemical formula wrongly, then you can't balance, you can't get the final equation. So just take note of this. Okay, so page 116, you can put a star here. This will help you to get a sense of the how to go about balancing equation. But if you are there already, then you can just go back and make sure you know how to do the chemical formulas properly. Okay, so deducing chemical formulas will be one big one. Next one would be writing chemical equations. Okay, so once you are done with all this, I think we are generally quite safe lah. Okay, but most people, as I mentioned, struggle with chemical formulas not because it is like very, very difficult based on the normal substances. They always struggle because of the polyatomic ions. Okay, your sulfate, nitrate. So they got more worked examples here. So take note how to go about doing this. Okay, I want to highlight as well, this work example actually is a good one for chemical equation. Why? It's because they are not balancing purely the elements, they're actually balancing it by the ions. Okay, so they're actually balancing by ions. So what you realize that in the top process for this equation, they say determine the ions present first and their valences. Okay, so they can write the unbalanced chemical equation. That's a step 1. So I know that they say iron 3 sulfate, so I got Fe3 plus, SO4 2 minus. React with barium nitrate, I got Ba2 plus, NO3 minus. What they form? Iron 3 nitrate, so this Fe3 plus and NO3 minus, and aqueous barium sulfate. Now actually it shouldn't be aqueous, this should be solid lah. Barium sulfate actually is solid. Okay, so barium sulfate over here, this will be Ba2 plus with SO4 2 minus. Now, once you identify the ions, then you can go about knowing go and determine their valency. So Fe3 plus, valency 3, SO4 2 minus, valency 2, Ba2 plus, valency 2, NO3 minus, valency is 1. Then you can go about doing the crisscross method and you can go about getting each of their formulas. So I want to highlight that this step of getting chemical formulas is critical. Okay, so once I go about knowing the chemical formulas, then I can write my unbalanced chemical equation. So this is my unbalanced chemical equation. So I'll just highlight in blue. So instead of writing left hand side, right hand side, right? So let me show you how I normally do it. So I'm going to write Fe2 bracket SO4. Let me zoom in. Okay, bracket 3 plus Ba bracket NO3 2 gives me Fe bracket NO3 3 plus BaSO4. Like that, correct. So I'm going to have one row for Fe, one row for SO4 2 minus, so Fe3 plus, one row for SO4 2 minus, one row for Ba2 plus, one row for NO3 minus. What I'm going to do here, see so Fe2SO4 3, actually I got 2 Fe3 plus. Okay, I got 3 SO4 2 minus. So what I'm going to do is, to simplify things, I'm just going to write 3 over here. Sorry, not 3 over here. 2 over here, because I know this row belongs to my Fe2 plus, this row belongs to my SO4 3 minus, blah blah blah, SO4 2 minus, Okay, so I'm going to write this dot 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 just to show you the row. So this one contains 2 Fe3 plus, 3 SO4 2 minus. There's Fe2SO4 3 don't have barium 2 plus, don't have NO3 minus. Barium nitrate contains 1 barium and 2 nitrate. So this will be for my reactants that I've drawn green line over here. And then on right hand side now is my product. So I got down here currently 1 Fe3 plus, 3 NO3 minus. Over here I got 1 barium, I got 1 sulfate. Okay, 1 barium, 1 sulfate. So what I'm gonna do here now is, first thing, let's do row by row. So Fe3 plus is the first thing. Let me balance my Fe3 plus. So I know left hand reactant I got 2, product I got 1. So I'm gonna put a big 2 here, which means that this thing is gonna multiply by 2. So I'm gonna get 2 iron. In terms of nitrate, because I put a 2 there, so it's now gonna be 3 times 2, it's gonna be 6. Okay? 6. So once I put a 2 here, it's 2 and 6, right? Now, the next thing I'm going to do, so once I balance iron, I won't go to the next row immediately. I'll actually go on to whatever that I've changed. So nitrate is Fe affected nitrate, so I'll balance nitrate now. So nitrate, I got 6 in the product side. I only got 2 on the reactant side. So how to get the 2 to become 6? I'll multiply by 3 for barium nitrate. So this is going to multiply by 3, multiply by 3. So this will be 3 here, 6 here. So now I know nitrate is balanced. Nitrate has affected barium, so I'm gonna do my barium next. So barium left hand side got 3, which is the reactant side. Product side only got 1, so I know that I must put a 3 over here. So times 3 times 3. So this will be 3 sulfate, 3 barium. So barium has affected my sulfate now. So next one I'm gonna balance is sulfate. So sulfate has 3 over here. Left hand side also got 3. So I know, okay, product and reactant side both has balanced out. Okay, so I've balanced this now. Let's go on to the next one. Okay, so you can try more practices on this. If you got any questions, definitely can go and do it lah. Okay, so this is how you go about balancing. The more complex one is by really using the ions per se. Okay, now last one we're gonna go through is ionic equation. Ionic equation itself. So for ionic equations, one of the key things you must take note is you need to be very familiar with the ions. Okay, so not knowing what the ions are is going to be detrimental for ionic equation. That's why it's called ionic equation, right? For a reason. Okay, so some reactions can be expressed using ionic equations. The ionic equation actually shows the ions. It shows the ions that take part in the reaction. Okay, they take part in the reaction. So anything that's not in the reaction, generally they are removed lah. Okay, they usually involve at least one aqueous reactant that's an ionic compound. Okay, so now let's look at this one over here. So to go to ionic equation, so it's actually the next step, right? So I mentioned first thing you always get word equation. From word equation you get your chemical equation. Okay, and from your word chemical equation, then you can get your ionic equation. Okay, there's really no simple way to just jump to the end lah. So let's look at this example here. I got sodium hydroxide aqueous plus HCl, hydrochloric acid. Then it becomes sodium chloride aqueous solution and then H2O liquid. So to do the ionic equation, first thing, you need to split up the ions. When can you split it up? You split the substance in the aqueous state, okay, into their constituents. So sodium hydroxide can split, HCl can split, NaCl can split. What will it become? So NaOH can split into Na plus, OH minus. HCl can split into H plus and Cl minus. So you must be very familiar ions are. Okay, NaCl can split into Na plus, Cl minus. Liquid state cannot split. So this is what happens now. Okay, I have my chemical equation split. I split the different substances into their ions. Once I split them up in step 2, the next step, I'll actually cancel all the ions that appear on both sides of the equations. They have the same charge and the state. So if I look at it here, Na plus AQ on the left hand side, Na plus AQ on the right hand side. So reactant and product side, I got both Na plus AQ. So I will strike them out. This thing that I strike out is known as my spectator ions. So they don't take part in the equation. Okay, they are just spectators. Next one, Cl minus aqueous, Cl minus aqueous. So you realize this Cl minus aqueous chloride ion never take part in the reaction as well, so I strike them out. Therefore, whatever that's left, you can see OH minus only on the left hand side, H plus only on the left hand side, right side only got H2O. So I will just combine them now without the whole, without all the ions that I strike out. This will be my ionic equation. Now this is also very classic. This is actually the ionic equation for acid alkali neutralization. So all your neutralization with acid alkali, if you ever do all this finding out what's the ionic equation, you will always get this OH minus plus H plus give you H2O liquid. Okay, so substances that remain unchanged in the physical state and do not take part in the reaction, they are called spectator ions, as I mentioned there. Okay, and they are removed from the ionic equation. In this case, in the question above, Na plus, Cl minus, they are the spectator ions. Okay, so there are some special cases that you need to take note. So sometimes we have aqueous covalent substances. So example, aqueous chlorine, aqueous iodine, even we have aqueous bromine. So these substances do not need to split, as again, do not need to be split into their ions when they dissolve in water. Okay? So let's look at this chemical equation, how they get. Let's do a bit of practice. So I got this chemical equation here. Let's split it out into ions. So as mentioned, let's try to change it to the aqueous. Let's look at this equation. So I got Cl2 gas, because it is not in the aqueous state, I'll just leave it as it is. 2Ki. So 2Ki actually, I got potassium iodide, which means I got K plus aqueous plus I minus aqueous. And you realize there's a 2 here. So it tells me that there's 2K plus and 2I minus, because it's 2 times of K, 2 times of I as well. So this is a typical mistake people will make. They forget that the 2 actually is involved for both potassium and iodide as well. So I split them already. So this is all in my reactant. Product wise, I got 2KCl. So once again, KCl, I can split it up to 2K plus aqueous plus 2Cl minus aqueous. Last one, I2 aqueous. As mentioned, iodine aqueous cannot split. So this will just be I2 aqueous. Where are my spectator ions? So I'm going to use green to cancel. Cl2, don't have. You realize, oh, K plus. Yes, K plus can cancel, because exactly the same in the reactor and product. The rest cannot, right? So once I strike out those two, which is my spectator ions, you will realize it will simplify into this ionic equation. Okay? So this is how you go about doing ionic equation. You definitely will require more practices. Okay? So this actually marks the end, but I don't want to just leave it like that. I think it's good to go through a bit more practices. So let's be a bit gung-ho. Let's be a bit gung-ho. So let's look at maybe this one over here. Magnesium oxide plus hydrochloric acid, give me magnesium chloride and water. Actually I don't want to do this one. Sorry, this one not so good. And let's use this one. Okay, let's do this one. So let's take this. Let's challenge ourselves. Let's find the balanced chemical equation. Okay, so you can actually pause here to do on your own. Then after that, you can see whether you get correct. So I'm going to do the balanced chemical equation for this. After that, I'll proceed to do the ionic equation. Okay, just to wrap up this whole question. So let's start here, balanced chemical equation. So I got aqueous copper 2 sulfate. So they already tell you it's aqueous. So copper 2 sulfate, I got Cu2 plus, I got SO4 2 minus, 2, 2, do my crisscross, I know I'm going to get CuSO4. Aqueous sodium hydroxide, so I got sodium Na plus, hydroxide is OH minus, 1, 1, crisscross, so I'm going to get NaOH. So this is aqueous, this is aqueous. Okay, so put by the side, not put below. Okay, I shouldn't write that. Let me write it properly for you. So CuSO4 bracket aqueous plus NaOH bracket aqueous gives me copper 2, solid copper 2 hydroxide. So copper 2 hydroxide is Cu2 plus OH minus 2 and 1 crisscross. So I'm going to get Cu bracket OH close 2. Okay, so 2 hydroxides, solid form, plus aqueous sodium sulfate. So sodium sulfate, let's write here, sodium sulfate SO4 2 minus. So I got 2, 1 crisscross over here. So I'm going to get Na2 plus Na2SO4 equals. Okay, so this is my equation that I have. First thing, you need to balance. After you get the chemical equation, remember always balance. Balance. So I'm just gonna straight away go balance. I won't go and do all the long steps. So I know that copper, one copper on the left and right side. Sulfate, one sulfate over left and right hand side, so equal. Sodium got 1 here, sodium got 2 over here. So I put a big 2. So I put in a big 2 there. My hydroxide now has doubled. Down here I got 2 hydroxides. So now I got my balanced chemical equation. So this is now I'm done with A. This is my answer for my balanced chemical equation. Now let's go on to do my ionic equation. So I'm going to need to split all of them up. So this is going to be a bit longer. So how to go about doing this? So copper 2 sulfate, let's split it up. So we're going to get Cu2 plus aqueous plus SO4 2 minus aqueous. Sodium hydroxide, take note I got 2 of them, is aqueous, so I can split them up into 2Na plus aqueous plus 2OH minus aqueous. Okay, very long there. So this is all under the reactant side. So this one is the reactant. Now let's look at the product. CuOH, copper hydroxide, solid. So I can't split them up because it's solid form. Okay, solid form, so no splitting. Sodium sulfate. Now take note, sodium is Na plus. So I got Na plus aqueous, 2 sodium, so 2 Na plus aqueous. Now, common mistake people tend to put is they put Na2, then they put a plus here like that. Now take note, this you must know what ions it form. Okay, don't just follow the formula. So I know that sodium form Na plus. The 2 here just tells you that there's 2 Na plus. So familiarity the ions is key. So I know that it is not Na2 plus. It is Na2 2 plus. So all this wrong. So it's actually 2 Na plus 1 SO4 2 minus aqueous. So now I need to cancel the spectator ions. So you realize sulfate can cancel, sodium can cancel. What I'm left with will be my final ionic equation will be Cu2 plus aqueous plus 2 OH minus aqueous, giving me Cu open bracket OH bracket 2 solid. Okay, so this is my ionic equation. So practicing this more will be will help you a lot. So in writing equations, generally few things you must always be mindful of is first thing, chemical formula. Second thing is to be familiar with the states of matter. Normally you can get the clue from the question itself. Third one, you need to be very familiar with balancing of equation. And the fourth one is about splitting of ions, and then from the splitting of ions, then you cancel spectator ions. Okay, these are some of the skills that you need to have in order for you to be able to get to your balanced chemical equation and your ionic equation. Okay, so that's all for this particular chapter.